Turbine, a win-win situation, the energy of the future.
In the United States, approximately 60% of each person's carbon footprint comes from their energy use at home, driving, and flying. The electric power industry's carbon emissions has already rose 5.9% since 2002 and 11.7% since 1998. As you can see in the pictures below, carbon emissions from fossil fuels causes several things, one of which being extreme weather. If global warming continues, we will experience more severe storms, frequent and intense heat waves, droughts, and wildfires. Another effect from carbon emissions is melting glaciers. If global warming continues and shelf ice in Greenland and Antarctica is lost, global sea levels could rise more than 20 feet, devastating coastal areas worldwide. Lastly, carbon emissions is forcing at least 279 species of plants and animals worldwide out of their habitats, moving closer to the poles. If global warming persists, more than 1 million species worldwide could be driven to extinction.
For several reasons that will be discussed later in this video, we believe wind energy is the best option for our environment.
Before you begin to assume that this is a complicated process, we will describe the process of using wind turbines for an energy source. First, you must understand that in the case of a wind electric turbine, the turbine blades are designed to capture the kinetic energy in wind. Although air seems so invisible, you must imagine it as a fluid in this case. Wind power all starts with the sun. When the sun heats up a certain area of land, the air around that landmass absorbs some of the heat. At a certain temperature, the hotter air begins to rise very quickly because it is lighter than the same volume of cool air. As we know, faster-moving particles exert more pressure than slower-moving particles. When the lighter hot air suddenly rises, cooler air flows in quickly to fill the gap that the hot air leaves behind. That leaves us with the wind. Going on, we will break down the process as we go on with each part of a wind turbine.
If you place an object like a rotor blade in the path of wind, the wind will push on it, transferring some of its own energy of motion to the blade. This is how a wind turbine captures energy from the wind. The same thing happens with a sailboat. When moving air pushes on the barrier of the sail, it causes the boat to move. The wind has transferred its own energy of motion to the sailboat.
The nacelle houses a generator and a gearbox. The spinning blades are attached to the generator through a series of gears. The gears increase the rotational speed of the blades to the generator speed of over 150 miles per hour. As the generator spins, electricity is produced as wind is collected. Wind turbine generators convert mechanical energy to electrical energy. Cooling on turbines is accomplished by encapsulating the generator in a duct, using a large fan for air cooling. Few manufacturers use water-cooled generators. Water-cooled generators may be built more compactly, which also gives some electrical efficiency advantages. Now that we understand wind turbines, groups of large wind turbines, called wind farms, are the most cost-efficient use of wind energy capacity. Wind turbines are grouped together to get the most electricity out of the wind resources available.
They are typically spaced far apart in rural areas with high wind speeds and little agricultural use of land. The cost of utility-scale wind power has come down dramatically in the last 2 decades due to technological and design advancements in turbine production and installation.
Wind power can make a difference. By 2020, the wind industry has a target of production equal to about 100 nuclear plants worth of capacity. The closest competitor to wind energy is corn ethanol, which could supply a bit more energy, but at a much greater cost. It costs us over $7 extra to save the fossil energy in a gallon of gas by subsidizing ethanol, yet we can save the same amount of energy at a cost of only 25 cents by subsidizing wind generation. That's over 28 times cheaper than fossil fuels. Like any other source of power generation, wind energy has its own advantages and disadvantages. However, we feel that wind energy can make a difference. To start off, wind power farms generate between 17 and 39 times as much power as they consume, as compared to 16 times for nuclear plants and 11 times for coal plants. Yearly, wind energy can eliminate 1,500 tons of carbon dioxide, 6.5 tons of sulfur dioxide, 3.2 tons of nitrogen oxides, and 60 pounds of mercury in 1 year from our air. In the United States alone, 50,000 wind-related jobs were created on average yearly. Currently, there are 42 states using utility-scale wind energy projects.
In conclusion, wind energy is the best option for our environment.